Today's talk here will be building your API for longevity. And really the reason that I like giving this talk is that over the last 10 years, I've had the chance to build APIs, use APIs, and I found out a couple different things. The first is building an API is actually really, really easy to do. It's really not that hard to write the code or use a framework like Grapes or Rails API or Jersey or AppAgility or the numerous ones out there. The second thing I realized is that people aren't really good at making long-lasting APIs. So let me just ask this. How many people here have used an API that has broken? Okay, so we all run the same pain point. So with this talk, the focus is really, well, how do we make an API that's going to last? Why should it last? What are the problems with versioning? And how can we make sure that what we build, our users are going to love, and it's not going to cost us more money in the long run? With that, we're not going to dive into a lot of code. Instead, it's going to be more principles, best practices, and then how can we actually create a more efficient process. Now, before we get started, like I said, I don't know what it is. I think it's Austin. Wonderful, wonderful city. I'm from San Francisco, so I love the fact that Austin's motto is stay weird. That's awesome. Plus, I love messing with other people's talks. So for this talk, I'm going to give out 5 books. Undisturbed Rest, the perfect guide to building your API or designing your API. And the way it works is if you tweet with the hashtag #LongLiveAPI, the 5 funniest tweets, I'll message you guys later and say, hey, come to the Dev Lounge, pick up a free book. Please bail me out on this. I did this at another event and literally got no tweets until the very last second with 20 tweets. And I chased people down, so please don't do that to me. But again, long live API. All right. I think we already know this, but is it fair to say APIs are changing the world? How many people here have used an API? Okay. How many people here have used something like a smartphone? Okay. How many people have driven a car? Okay. If you've used those, you've probably used an API. In fact, today there are over 15,000 public APIs listed on programmabweb.com. 15,000 public APIs connecting all sorts of devices. But that's really just the tip of the iceberg. If you think about it, there are hundreds of thousands, if not millions of more APIs connecting mobile apps, internal for business uses, connecting departments. So today APIs are connecting a lot of different things. Obviously they're connecting our mobile apps, they're connecting enterprise architectures, but they're connecting phones. They're connecting watches with the Apple Watch and the Android watches, glasses, cars, refrigerators. I was at Samsung's conference a couple years ago and they had a smart refrigerator that would tell you when you were starting to run low on food. Thermostats, in-home robots, and a lot more. And I want you to think about that for a second. Think about all the things that APIs are connecting and how important it is. Imagine for a second you're at home and you have your home security system and the worst thing possible happens. Someone breaks into your house. The alarm starts going off. Update required. That's probably not a good thing. And if we look at microservices, the last thing we want to do is deploy 700 microservices out there that are dependent on API and then find out that API broke and now we have to go back and update 700 microservices that may be composed upon it. In order for APIs to work, in order for IoT to work, in order for microservices to work, they do require a matter of persistence among the APIs. Not only that, but the truth is, versioning and making changes is really, really expensive for everyone. It's not just you that has to go in and say, we're going to rebuild our API or refactor our code, but all your users, all your company departments that rely on that API. Now here's my Bailey Mays sales pitch for the day. Thankfully, with 5 simple steps, you can build an API that's designed to last. The first thing is going with a long-term mindset. This sounds like common sense, but a lot of people go in and say, we're going to build this API, we're going to get it out there, we'll get feedback, and then we'll version it, which never works. Understand what you're building. Again, it seems like common sense, but most people who APIs that get developed are developed on the fly without true understanding of what they are actually building. Utilize something called spec-driven development, which we'll talk about. Incorporate best practices. And then as you do this, repeat steps 1 through 4. So first thing is think long-term. Your API is a contract. And we forget that unlike an Agile web application, where we say, well, we're going to launch it, and then we can make changes as we go, you can't break changes in your API without affecting your users, without causing their systems to go down. Versioning is also not a solution. And my favorite one that gets me in trouble, you're really bad at long-term design. How many people here think they're good at design? This is a great group. Okay, we got one person, two people, awesome, three, okay. See, one hand goes over like, yes, I'm good at design. Let me ask you this. How many people here have written code? Okay. And how many people have looked at your code a year later and said, this is the most amazing thing ever, I wouldn't have changed anything? How many people have been writing code and you've extended a class and you're like, this is great. You extend a class, you're like, this is even better. You extend a class, you're like, I'm a genius. And you extend it one more time and you're like, crap, I'm stuck. We're really good at solving the problem short term, but not long term. And much like security with API design, you can pay a little bit more now or a lot more later. So you need to think things through, and again, mindset is everything. When I say mindset is everything, I'm a big basketball fan. You wouldn't want a team walking into a basketball game going, we're gonna lose. We're gonna lose. Because chances are they're not gonna win. Same thing with API design. When I say your API is a contract, we forget that when we make that change, we are taking away the ability of our consumers to make money. When we change our API, whether it's other departments in our company or our consumers, they have to say, wait, I have to stop everything I'm doing, go back and fix things because you broke it. Which means they're not adding new features, they're not making more money, and they're realistically not paying you more money because they're still trying to fix things versus gaining new customers. And that means, again, you have to think through every aspect of your API before building it. And these seem like basic questions and common sense, but again, they get missed quite a bit. First, who is your API for? What type of API are you building? How are you going to maintain your API? A lot of companies out there say, look, we're going to build an API, push it out there, and that's it. I promise you, that's not it. You'll have to maintain it, there'll be security patches. How are you going to document your API? Are you going to have a full documentation team? Are you going to use the Swagger console? Are you using something like RAML? How are you going to let users interact with your API? How are you going to handle little things like authentication, provisioning, throttling, security risks, DDoS attacks, developers using infinite loops by accident, not that I'd ever do that. And how are you going to manage support? And these don't have to necessarily be really tough discussions that you have to have. Support might be, well, we're going to have a dedicated API support team, or engineers will provide support, or we're going to have a community forum, or we're really not that invested in the API, so good luck. If they need support, they can figure it out. Who are your end users? Is it going to be current customers? Is it going to be business partners, third-party services, or developers? And this is important because before you can build this, you have to understand who they are and what they need. So what actions do they need access to? And this means involving your users from day one. When I started off as a web developer, I was new to the field, I was a rookie, if you will, and I got this photography client. And she told me, I'm looking for this beautiful photography website, I want this type of imagery, this type of font, gave me the specs. And I went out there and I built the most beautiful photography website on the planet, in my opinion. And I sent it to her, and she looked at it and she said, what is this? You're using dark colors. I do wedding photography. I want white colors. Use this image. I want this image. Use this font. I want that font. And so this site I poured my heart into and built out, turned out she hated it because I didn't involve her in the design process. I didn't ask her what she was looking for. And we do the same thing with APIs. List out why you're making the API. At MuleSoft, we do with a lot of enterprise customers, and they say, hey, we want an API. Like, that's great. What's your API going to do? We're going to share our services and data with the world. Okay, but what data do they want? What services are they going to have access to? How are they going to interact with your existing services or other APIs? How they interact with other APIs or other services that they might need to use with your service from third parties? What actions do they need to be able to handle? And again, one of the traps we run into is we say, we're going to build a REST API, we're going to do CRUD, we're going to do the HTTP methods. We start thinking post, put, patch, delete right away. Take a step back and say, they need to be able to add a user, edit a user, retrieve a password possibly, send a message. And this is for the engineers in the room because, let's be honest, we're horrible at this. Do only what is necessary. Don't get fancy with your API. You're really creating a foundation, and like any foundation, you'll be able to build onto it and build onto it more. So list out what actions your users need to be able to do. This is a really simple way to really organize our API. We simply say we're going to have users. They need to be able to create a user, edit a user, et cetera, et cetera. We're going to have a messaging system. Here's our messages, actions that we need. Products, we need to be able to review a product, add a product to the cart, cart, obviously you need to be able to check out. But as we do this, we start doing a couple different things. The first is, you'll notice we've already defined our resources without even trying. Well, we have all this stuff for users, we'll have a users resource. All this stuff for messages, messages resource. The other thing you'll notice is that we have duplicates on there. We have message a user and send a message. Well, it might not make sense to actually have a resource specifically under users for sending a message. That seems like we're kind of being redundant. However, what we have done is we get our chance to look at where does it belong. So we can say, wow, send a message or message belongs under messages, but also develop the relationship link between the two. So rather than going back afterwards and saying, let's create a hypermedia map and link all these things together after the fact, we've already created a hypermedia map. We already know that when we pull up a user, we need the ability to send them a message, and that's going to be a link on there. Also, what type of API are you building? Are you going to build a REST API, a partial REST API, SOAP, RPC? Let me ask you guys this. What's the right type of API to build? Which kind? It depends. Absolutely. So I get myself in trouble because everyone's like, REST, yes, absolutely. Well, if you're a large enterprise and all your customers are legacy customers and they aren't ready for a REST API, but they need SOAP because they have the SOAP libraries, SOAP probably makes sense. That's why Salesforce for the longest time maintained a SOAP API and a REST API because it's what their clients demanded. Why are you building the API in that format? Do you understand the pros and cons of the format that you're choosing? What's it mean for your development time? What's it mean for usability for your users? And what's it mean for longevity? How's it going to affect you long term? So the first thing is understanding that each of these API types has pros and cons. For SOAP, we can say, look, SOAP, it's archaic, it's all this huge SOAP package that needs SOAP libraries, it's only XML. But SOAP has a WSDL, which some people prefer, and it can be stateful or stateless, which is kind of nice. RPC, on the other hand, is really, really easy to use. It returns back one format, so it's JSON RPC or XML RPC, but there's really no on-ramp to get to it. It's, I call this URL, I get this back, and I do a get or a post, and that's it. And finally, REST, which has all these great benefits, but has some caveats with it as well, and is a bit more difficult for developers to use, especially when we start incorporating things like hypermedia, because it's always easier to hard code a link than it is to actually use it dynamically. So if you say, we're going to build a REST API, we're going to go for longevity, we're going to go for flexibility, we're going to go for agility, do you understand what REST means? Do you understand that the client and server have to be able to separately evolve, and that changes you make to your mobile device shouldn't affect the server at all, or the client shouldn't affect the server? That REST is stateless, meaning you do not store state on the server side. Of course, clients can store state, but you don't keep a record of the calls they're making. So if I make 2 calls in a row here, you don't remember the first call, you don't care about the first call, you take each call as it is, as its own. It's cacheable, meaning that you not only provide caching obviously on your end, but you tell your users, here's how you cache this page, or here's what you can do to cache this page, here's the time limit. This isn't cacheable, this is going to be cached across all layers. The uniform contract, layered system, which as we're talking about microservices, is just basically having different components in your architecture to keep the API up. And then the last one is code on demand. And code on demand is an optional constraint, but that's actually sending code over the API to your users, such as sending a servlet or functional programming code. But here's the thing, most APIs are not RESTful. So as we talk about APIs and say we're going to build REST, Roy Fielding, who created the dissertation around REST, or the theory of REST, kind of went off one day where he said, look, nobody's using hypermedia. And he went so far as to say, is there a broken manual? Is the documentation wrong? What do I do wrong to make it not clear that if it doesn't have hypermedia, it's not REST? Does that mean that you have to build a full, completely RESTful API? Absolutely not. You have to build the API that meets your standards, meets your needs, but you need to understand why. One of the reasons for that is, a company had the chance to build an API, they said we're going to build REST, they started off with it, and they went down and down and down, and pretty soon they're saying, well, we're going to have them send us HTML, and then we'll send them JSON. And then it was, and we're going to do a post, but they're going to send the data through the query string. And they started tweaking things because they thought this will make things easier and better for our users. Without understanding what they were building, they actually created more problems, more iterations, and spent a lot of money trying to build this API. So again, understand why you're building one type of API over the other. If you don't, you're going to pay a lot more down the road, and you're going to have an API that's kind of a mix of all things and isn't going to work. It also means building your API for beyond today. And that's our challenge we run into is we say, this is the API, these are the needs we have, this is our platform. That's great, but what's your platform going to be like in 2 years, 3 years, 5 years? Again, we're really, really good at short-term design. But as Roy Fielding says, we're awful at long-term design. And that brings us to versioning. And versioning is a necessary evil. Again, we say we're going to version, and it's going to be great, but versioning has problems. First and foremost, versioning creates backwards incompatibilities, which means that the apps relying on your API, your consumers, they're going to break. And when they break, you're going to get complaints. The second is there's multiple services to maintain and multiple systems to support. And you may say, no, that's not how it works. We're going to deprecate this API, we're not going to support it anymore, and we'll release the new API. Well, that sounds great in theory until there's a security risk, and you have to patch that security bug. Or you get that $1 million customer who says, you know what? Actually, we're stuck on the old API, we can't upgrade yet, and we need this feature. Or another department in your company says we need it. Before MuleSoft, I had the chance to work as a developer evangelist for Constant Contact. And really my entire job there was to get people to upgrade from version 1 to version 2. And during the year I was there, I was able to get, I think, 4 people to upgrade their APIs. Nobody wanted to upgrade their API. They're like, this one works. Why should we go back and spend money to fix something that's not broken? Another problem is it creates confusion among developers. Again, at Constant Contact, one day I had a call, and the gentleman on the line said, I have a problem. The API is not working. I'm like, okay, so what version of the API are you using? And he looks at me and goes, yours. Okay, no problem. I mean, sometimes people get confused about version 1 versus version 2. I was like, okay, how does it work? He goes, well, I send a post and I get data back. Okay. Are you getting XML or JSON? Yes. Well, it turns out that he was taking over for another developer who just said this didn't work. He called to figure out why it wasn't working, hand dug in, didn't know what version of API we were using, and it took about 20 minutes just to figure out what version he was on. And it turns out he was on version 2, yay, except for the feature he needed was on version 1, which he was really ticked off because they just upgraded from version 1 to version 2 and didn't have everything in version 2 yet. So again, developer adoption is nearly impossible. It's going to create confusion, and you're going to end up supporting both APIs. But there are times when you need to version. You do need to version your API when you have backwards incompatible platform changes. So if anybody watches the show Silicon Valley and Pied Piper goes from saying, hey, we're going to be an algorithm to a media company, in that case, it might make sense to change your API to reflect what you're doing now. Or you're an auto shop and now you're a bakery. Okay, it makes sense to change your API. The second time is your API is no longer extendable. In other words, we messed up. We thought we had the perfect API, we kept changing, improving, and we got stuck. And now we're in trouble. Or your spec is out of date. Maybe they want JSON and you're using SOAP with XML. So you need to update your API. But you shouldn't version your API just because you added new endpoints or you added additional data in the response. There's the argument about strict schemas. Unless you're doing something that requires strict schemas, I'd avoid saying this is the strict schema for our data response. Be flexible in that. You changed technologies. You went from Java to Ruby, which is apparently a new language. Oh, perfect, I fixed that. For the longest time, I actually had a typo in my slide, so I'm happy that was fixed. Or you changed your application services. You should be able to change the code, you should be able to change your services, you should be able to change your dependencies without affecting the interface of the API. This is another challenge we see, by the way, is we have companies that say, you can generate an API based on your database. We'll create the API based on your database names. And that's actually okay if you create a unique interface, if you go back and you start changing all those and you decouple it from the database. The problem is that once you say, okay, we use this database, we're going to move to a CRM, all those names are strictly aligned to the database, you're tightly coupled. Same thing if you're saying, look, we have a CRM and we're going to represent a CRM on, through our systems. If you're using a specific API or a specific system and your API on top of that is tightly coupled, the second you change that, you're breaking the interface, and that's what breaks backwards compatibility. Versioning does not excuse poor design. That's very, very important to point out that versioning is not a solution. It's actually going to create more problems down the road. And a poorly designed API is going to cost you far, far more in the long run than the short run. One of the stories I'm not proud of is I had the chance before I joined MuleSoft to work as a contractor, and we built this API. And we spent 6 months writing the code, and we built this perfect API. I mean, it followed all the best practices and best standards. The code was perfect, I know because I wrote it. By the way, thank you guys for not laughing. Usually I say that, and people are just laughing for some reason. And we released this API after 6 months. And 3 weeks later, we realized no one was using it. No one was using the API, not because of the code. Code, again, was good. Not because of best practices. It was a great REST-based API. But because it didn't meet their needs. And so we spent the next 3 months trying to salvage this API, trying to fix this API, before finally scrapping it and throwing it away. So we talk about the cost associated with this. That's 10 months, 10 months worth of work that got completely thrown away because it couldn't meet our customers' needs, because we didn't spend 2 weeks at the very beginning saying, does this work for you? We didn't involve our users. So the way that we can avoid that is using something called spec-driven development. And the way spec-driven development works is the first thing we're going to do is define our API before we write any code. We're also going to bring in design patterns and code reuse. We do this with all our applications. Why don't we do it with our API designs? We're going to mock our API and get user feedback from our users before we write a single line of code, make the necessary changes, and then start going to the specification and not deviating. So specifications become the source of truth. So what you have really is a two-stage Agile process. We have an Agile design process to develop the contract, and then an Agile development process where you can use test-driven development to actually develop the code. And the reason for this is that way nothing's going in the code and nothing's going in the design that we haven't tested and we're not sure about. So again, the way it looks, first we're going to say, hey, we're going to design our API. We're going to design the API, we're going to mock it out, get user feedback, make any changes, test it, make sure it's perfect. Then we'll go into development. But what happens if you run into an issue in development where you're like, hey, this was a great idea in theory, but it doesn't work? You simply go back to the design process, fix it in your test, make sure it works, test it with your users, and then move forward. And what you're doing now is you're creating an API, not only that your users are going to love and it's going to meet their needs and get to test against real-world use cases, but it's also without design flaws. And when I say without design flaws, I'm going to pick on a giant social media API here. I'm not going to say their name because I don't want to get sued, but let's just say it starts with a face and ends with a book. On their API, they have a resource, and it's a great resource where if you want to search this resource by age, you have to put age in one way in the JSON. If you want to search by location, it's a completely different way. If you want to search by age and location, it's a third way altogether. So this wasn't done because they're like, oh, there's these dependencies. It was done because they had different developers working on it, and they didn't realize that they had this set up. So what's the Agile design cycle look like? Again, design the API, get user feedback after you mock it, validate, does this meet our needs? Does it meet their needs? Is it a good design? If not, keep continuing working on it until you get the design perfected, and then when you're ready, move into the coding stage. And really the goal here is that we're going to let our developers develop fearlessly. We don't want to have our developers look at the API and say, okay, we're building this resource. Hey, question for you. How did you set up that data? Did you use camel case or snake case? And are you using a put or a patch to handle that? And is that data encased in a data object? Or, how do we separate that? You don't want to run in those issues. You don't want those inconsistencies because that's what's going to cause your API to break. Of course, the problem is, up until now, that's been pretty darn expensive. We say, hey, we're going to build up this API. We have to do an MVC, go and change the code. Doesn't work. The good news is today there are several new specifications that are going to make this very, very easy. The other nice thing about this is these same specifications handle a lot more for you. So you're not just designing your API and then throwing that away, like we do with Waterfall and say, here's the documentation, I'll throw it. Now you have a spec that can be used to generate your documentation, that can be used to generate your test-driven development tests. You have a spec that can be used to create SDKs and client generators, create interactive scenarios, all these different things. So some of today's specs out there, the first is RAML, which is the RESTful API modeling language. The second is IODocs, which was by Mashery. Here's my disclaimer on IODocs. I wouldn't recommend using it simply because typical mastery has actually moved towards Swagger, so they're really not maintaining as much anymore. You have Swagger or the Open API Initiative, which is another great and very popular specification out there. And then you have API Blueprint, which is fantastic when it comes to documentation. It has some great tools out there as well. Now, myself, I'm a fan of RAML. I'm a fan of RAML for a couple different reasons. But with RAML, what you can do is you can define your API in a few lines of text, really. You can see what your API will look like as you go with the API designer. You can quickly prototype your API for developers to try out. That means with a click of a button, or if you want to install an open source script, you can send this API around the world, let your developers try it out in real time. You can quickly make tweaks and changes when you find design flaws. You can easily document your API. You can let developers try your API online. Another great feature with RAML is there's something called the API notebook. What that means is rather than have your developers or your potential developers say, hey, here's our API, what do you think? You can send them an API notebook, and without having to write any code outside of my or JavaScript, they can actually test your API using real world use cases to see does it meet their needs. You can let developers try your API online. You can let developers interact with your and other APIs, again, through the API notebook. And then if you want SDKs, client generators, code wrappers, libraries, even your frameworks for building the API, you can generate those both through the open source community. But if you're creating SDKs for public consumption, I would really lean towards using a professional company like APImatic.io or Rust United, just because whether you're using RAML or Swagger, a lot of the open source client generators are kind of sketchy. Most importantly, and this is the real reason why I prefer RAML over Swagger, you can use data models and design patterns, which means, again, we're saying this is what our API looks like, it stays consistent, and you can reuse code. You can pull in libraries, which is basically if you have a user's object that's shared across multiple APIs, you can pull that in a namespace manner. You can create overlays, so you can have one specification that you can then overlay for your dev environment, your QA environment, your stage and production, etc. So in this case, we're saying, look, we want to have a resource type of collection. So for our collections where we're going to get multiple items at once, our gets, here's a sample description, here's an example. Rather than have to write all this again and again, we simply have to say example collection, and that automatically pulls the rest in for us. And again, as we go, you'll see that we're designing our API here. We automatically get, our followers resource has a post to get. We can dive into that, see what those look like, and actually try those out using the mock API to see the responses that we get. So what's RAML look like? This is the other reason why I love RAML, by the way. RAML is very verbose and very complex. So I need your help here. So if I want to create a resource and I want to call a resource playlist, how would I define that in the RAML file? Anybody? /playlist, just like I would on the API. And if I want to add a get method to playlist, how would I add a get method? Get. And if I want to have 200 response, what status code do I use to put in a 200 response? Exactly. So it's very easy to get started with. And the nice thing about RAML is that it doesn't matter if you're a developer, if you're a tech writer, if you're a CEO. You can even let your CEO modify your API documentation. That's up to you. I'm not going to go too deep in RAML here, but again, it's an open source specification. You can check out raml.org. Otherwise, there's these awesome little pocket guides. I have several in the back here, or you can pick them up in the dev lounge. It's kind of how to get started with RAML. But again, you want to use the specification whether it's RAML or Swagger as you build out your API. But remember that it's not a one and done. Once you start designing your API, every time you're going to make a change, you're going to run through these tests. And the reason for this is you can design the perfect foundation, and then you start building things incorrectly on top of it, and now you're showing your lifespan. If you build the foundation of your house, you're not going to start adding 10 rooms to the house, that's a big house, without having a blueprint. Otherwise, pretty soon you're going to have a brick wall that has a window facing it. You don't want to run into that. Also, you want to incorporate best practices into your API. So as you look at best practices, you want to use nouns over verbs, utilize the HTTP methods or CRUD, utilize hypermedia, use accept and content type headers, return header codes, return descriptive error messages, and there's a lot more, but we don't have time to go into all of them. The first thing is you should be using nouns, not verbs. The reason for this is with REST, resources are used to identify the object you're modifying. So you're going to say users, and then use the HTTP methods themselves to say I want to get a user, I want to modify a user, I want to delete a user. If you find yourself using verbs, you're actually falling into what we call the RPC trap. And this is also one of the reasons why we encourage API design first, is if you're working on an email API, for example, it's very easy to say, oh, we have an email API, we need a send resource. Well, wait, but that's a verb. Now, how do we handle that? With the designs phase, you can take a step back and say, well, let's try send, let's try renaming it, and you're able to rename it and try different things with your users without spending any real time or energy. It's modifying text. And so you could have it be something like emails or messages. Also, make sure that your resources are plural, except for when they can only and always be singular. So in this case, we're going to have addresses and not address. And you may say, well, wait, our users have just one address. And that's fine, but is there potential in the future for them to have multiple addresses? Could they have a shipping address and a billing address? If the answer is yes, in the future it could become plural. Start with plural now. That way you don't have to change the resource down the road. Take advantage of CRUD. CRUD stands for create, read, update, and delete. And with this, mostly focus on the HTTP methods. Know which method does what. So if you're going to create an object, use a post. If you're going to read or get an object, use a get. Update an object using put or patch, and understand the difference between them. And of course, to delete, using delete. It's really important to understand the HTTP methods, though, because there are some weird things you can do. For example, if I use a put versus a patch, a put is a complete override of the data. So if I say, look, I have a record where first name's Mike, last name's Stowe, city San Francisco, and I want to move to Austin. So I send a put, and the only thing I send is city Austin. That record will now read first name blank, last name blank, city Austin. A patch, on the other hand, patches the data. So I do the exact same thing, first name Mike, last name Stowe, city Austin, everything's left intact. So understand the difference, but also understand that a lot of users won't know that put and patch act differently. So explain them, especially if you use both. Also, beware of using put to create new items. With the HTTP method put, you can use put to create a new object if an explicit ID is provided and that ID does not exist. The problem is that most developers aren't going to be expecting to create a new object if they do a put. They'll be expecting to get error back saying, this doesn't exist, I couldn't modify it. So if you decide to kind of use that optional route there, make sure you return the right status code and say, here, you got 201, not a 200. Otherwise, I'm not going to realize something was created versus updated. So in general practice, just try to avoid doing that. And then also keep in mind that posts can be used to do other things as well. Posts can be used for searches or advanced types of methods within your API. It doesn't always have to be create, but to create something, that's the general rule. Also take advantage of hypermedia, or hypermedia as the engine of application state. How many people here have used hypermedia? A couple people, okay. How many people here have used something called the World Wide Web? Okay, if you've used the internet, you've probably come across something called HTML, which is the hypertext markup language. Hypermedia is just an extension of hypertext. All it is links. It's a way of saying this is the relationship between this. And where hypermedia becomes so important in REST is REST doesn't provide state. So if we have 3 users here, I'll pick on you. He's the admin here. He's the guy in charge. We have you, you're our awesome user, and we have me, and I've been the spammer. I'm like that horrible guy. And you do a get on the user's collection. You get us 3 back. How do you know what options you have? Because obviously you can't delete the administrator because that's a bad thing. You can't give me special privileges because I'm a spammer, and so I've been suspended. And with this guy, he's doing great, but maybe you want to suspend him, or maybe you want to make him an admin. How do you know what you can do with that object? And the answer is the hypermedia links. With him, you'd have links saying, hey, get the user, add the user. You can't suspend him, you can't delete him. For him, you'd say, hey, get the user, add the user, suspend the user, delete the user, make an admin. For me, you'd get, you should delete this user, why do you still have him on your list? So it's going to tell, again, the relationship or the status of that object. And that's what HeyDAS really means. There are already several popular hypertext links out there, or specs out there. The first is HAL, which is a very popular specification. The second one is JSON-LD, which is a W3C standard, but was really designed for linking definitions between databases. So I'd actually avoid using that one. JSON API is a very, very popular hypermedia format, which I highly recommend. Collection plus JSON was one of the original ones created by Mike Amundsen, which is a great specification. But I would still lean towards HAL or JSON API. Siren's actually really interesting in that it went a different direction. Siren actually says, here are the form properties, here's the class properties, the entity properties, and by the way, it's action driven. And then CPHL, I put the asterisk on because that's actually mine, is also action driven. And so the idea is, do you want to be resource driven or action driven? That's something to look at because you want to make sure the hypermedia is providing information not just for the developer, but also for the machine to interpret it. So what's hypertext or hypermedia look like? In this case, we're getting back a user, and here are our links for that user. So with HAL edit, there would actually probably be self versus edit. With CPHL, it would be the actual action. And then with HAL, you say, here's a link for that user. With CPHL, because it's action-driven, you can say, here's the methods. You can do a put or patch against that. Same thing for the next one. Here's messages. You do a post. So those are the different things that would show you the difference between HAL and CPHL. But again, the concept's the same. Same thing with JSON API. What you have is you have links, which say, here are your next options, or a choose your own adventure storybook, if you will, as Keith Casey, a friend of mine, likes to say. Also use except and content type headers. This is the other mistake we tend to make with APIs, is we say, we're going to build a JSON REST API. It's going to be awesome, which is great until, again, you get that $1 million customer who says, we need XML. And then you say, okay, we're going to go back and refactor the entire API for this customer. You should build your API with the ability to add content types in the future. You may say, we're only support JSON now. But what happens if YAML becomes the next big thing and replaces JSON just like JSON replaced XML? Or if there's a new specification? Or with hypermedia, well, people are using HAL and they say, actually, HAL is great, but here's this great new specification, let's use this instead. So you want the ability to adjust based on your needs and have that flexibility built into your architecture and your API interface. So right now, the most common ones, obviously, are going to be application JSON and application XML. But you want to give yourself the ability to support multiple specifications without worrying about breaking backwards compatibility. Also, use response codes. I get myself in trouble. I was looking at a guideline doc the other day, and they said, use 3 response codes. Use 200, 400, and 500 to tell people what went wrong. Don't do that. The truth is, if I want to know the status code, if this is an error, is it successful, I can look at the first number and know this is a 200, it was a success. This is a 300, it's a redirect. This is a 400, client error. But give me more information. So tell me what actually happened. If I did a get or I did an update, 200, it's okay. However, if something was created, I do a post or a put and something's created, 201, tell me explicitly it was created. I do a put or a patch and nothing's modified, 304. I send the wrong data or send the wrong format request, bad request. I haven't logged in or I sent an invalid auth token, not authorized. I try to do something not allowed to do, forbidden. 404, the object never existed and it's not there. Technically, you'll want to use the status code for gone if it once existed, but 404 is traditionally not found. 405, method not allowed. I try to do a delete, I can't do a delete. It actually tells me not just forbidden, but hey, you can't do this. If you try a different method, that would work. 415, I try to get XML. You only support JSON. And 500, we have absolutely no idea what happened. Or if you're feeling super creative, you can use the official status code 418, I'm a teapot. You should probably do that if, in fact, your server is a teapot. And 420, which is non-official status code, was actually one that Twitter created for too many requests. They say it's enhance your calm. I really don't get that one, but the correct status code there would be 429. Also, use descriptive error messages. This is one of the biggest pain points in that you call an API and you get back an error that says something went wrong. I know something went wrong, it didn't work. Or my favorite was, we're out building a rocket ship, check back later. This was actually a company here in Texas, and I nearly drove from Minnesota to Texas to see this rocket ship. Instead, tell the user what went wrong. So if you have a customer support status code, here's the status code. Give them the error message, missing a user ID, but then tell them why there's an error. The user ID is required to edit a user. That makes sense. And then give them a link back to documentation saying, here's how you can find out more. Here's how you can solve the problem. Because the reality is, if a developer can't use your API and can't figure out what the problem is, they're going to use your competitor's API or an API they can figure out. Also, don't reinvent the wheel. There are several great specifications out there already. There's vnd.error, which is a great specification. Google Errors, which is personally my favorite one out there. And then JSON API, if you're using that for hypermedia, they actually have an error format as well. Also, and this sounds really silly, keep your documentation up to date and in sync with your API. Again, this is one of the reasons I really recommend the spec-driven development approach. Your documentation is always in sync with your API, it's easily generated. But as I was consulting with another company on their API, one of their biz dev guys came to me and said, hey, he goes, we're really glad you're helping us out here. We need to build a new API. I said, okay, well, why do you guys need to build a new API? And he said, well, it's broken. He goes, developers try using our documentation, it doesn't work. And what happened was their documentation was out of sync. What he saw was the API doesn't work. In the end, it was all you have to do is update your documentation, it's great. But without them looking at that, they would have rebuilt a whole API and killed off the old API just for that reason. And finally, as you do API development and design, go in with a long-term mindset. Everything you should do should be designed to last. Understand what is that you're actually building, what type of API, and stick to those standards. Utilize spectrum development, and of course, incorporate best practices. Because it only takes one tiny little thing, just one mistake in your API that goes to production. Then just like Facebook, they have this error in production, or this issue in production. They can't change it. They know it's there, but the second they change it, they break it for the thousands, if not millions of users that are using that resource. And that's kind of put them in a corner with that resource. Last but not least, remember, building an API is really, really easy. Again, all these great frameworks out there, but designing an API, that's the most difficult thing. And so you want to spend your time there and say, let's get the design right, and everything will follow. With that, I will finally shut up and open up for any questions if they're there. Otherwise, you can get a complimentary copy of Undisturbed REST at MuleSoft.com/RESTbook. Again, if you tweet long live API, your funniest tweet, I'm giving out 5 hard copies. And also feel free to grab up a RAML Pocket Guide if you want to learn more about RAML. With that, any questions? Oh, yes, sir.
So earlier you were talking about versioning your APIs and kind of some of the either justification to version or not to version your API.
Mm-hmm.
What are your thoughts around major versus minor versioning APIs? Like, do you follow a Semper type versioning pattern, or do you stick just to major versions?
I would stick just to major versions. I mean, the idea is that your API should almost act as a web page, where you don't want to go to yahoo.1.1, yahoo.1.2. You just want to go to yahoo.com and be on the latest version. Your API, you should be using release notes. You should be, sending updates to your list and saying, here's what's changed. And if you have an API gateway with management, that's going to help you notify your users. But the developer shouldn't say, am I on 1.1 or 1.2? That shouldn't matter to them. It should automatically be pulled in. Any other questions? Yes.
You covered, building this before you build your code, but a lot of times we're brought into some other project that has SOAP and you got to get rid of it. Where do you start from there?
So if you have a pre-existing API, like a REST API that you're building, I would still start at the design process. And you can say, look, this is the SOAP API. This is what the SOAP API does. You kind of already have the who's it for, what's it do, what actions do we need, and then you're just going to design out on like the RAML or the Swagger to do it that way, and then continue the process. And even then, it's still a great idea to send it to these customers and say, does this meet your needs? Because you may have a design flaw that you don't see. Now, on the other hand, if you're saying, look, we have an API, REST API, how do we start doing the design first approach there? The easiest way is you kind of sell the spec backwards. You say, hey, look, do you know with RAML or Swagger, we can automatically generate our documentation, which means our APIs can be in sync and our tech writers just update the descriptions and makes their life easier. By the way, it's not to replace technical writers. You still need somebody who can speak the language and say, here's how you use the API. By the way, it can also create SDKs. So as we're working on our mobile apps, we can actually generate those mobile app SDKs for them or create more awareness. For example, if you go to developer.spotify.com, Spotify uses RAML, and their entire reference guide as well as their interactive console is all based on RAML, where that's automatically generated from that RAML spec. So you can kind of sell the goodness that way, and then all of a sudden you have the spec that you can say, oh, by the way, since we have the spec, why don't we just try making another version and get user feedback before we push this in production? And so you can kind of roll it in that way. Any other questions? I don't want to keep you guys from lunch, so. All right, with that, thank you very much.